Hi everyone, my name is Nicole Imholtz and I'm the ARC CBBC Research Coordinator in Groningen. Here we study how to use resources derived from biomass to make all kinds of interesting new chemical building blocks and materials with bio-inspired properties. Let's have a look at the infrastructure, the facilities and the research here in Groningen. To synthesize new building blocks out of biomass, we develop new homogeneous catalysts. Some tools come in very handy to screen and synthesize new catalysts, such as carousel reactors that Hangqin is using over here. It can perform 12 reactions in parallel. Microwave reactors allow to work in a controlled way at high temperature and pressure. And the latest addition to the reactor family, the polyblock.
This is the polyblock. There's an electric device and a heating device and a cooling device. And we have this kind of gas cables we can attach to the reactor vial. And we can use overhead steering for better mixture. And then, for example, a gas balloon or a gas bottle can be attached as well, for example, for oxidation with oxygen in water.
Others are working on photocatalysis to discover new chemical transformations using visible light.
This metal block, and then here from the bottom I can put here different LEDs that look like this. And then I can put the solutions in here, put on the steering, and then I can turn off the light.
Once you found the right catalyst to synthesize your compound, time to upscale. George can tell you about his home-built Rotary Evaporator setup to photo-oxidize for Varal.
A tiny amount of solution inside a very large flasks creates a very thin film in which we can irradiate this thin film perfectly. Furthermore, instead of having a vacuum line on the rotary evaporator, we replace this with an oxygen balloon, so we have an oxygen atmosphere to perform our photo-oxidation reaction. By having this very tiny film, we can do this photo-oxidation very efficiently.
Speaking of photocatalysis, meet our new assistant professor Sebastian Bao.
Hello everybody, my name is Sebastian Bao. I'm from Germany and I started here as an assistant professor in the ARC CBBC in Groningen. And I'm working on new redox transformations purely funneled by electricity and by visible light catalysis. And mainly on the heterogeneous catalysis directly at the electrodes. For the photoredox catalysis, it's a purely homogeneous catalysis process for these small photoreactors. Most of the reactions will run in this batch setups, but also we are planning to incorporate these batch reactions into continuous flow setups.
Time to assemble the new building blocks into coatings. But what exactly happens within a coating as it dries? Linda can show you with Raman microscopy.
The focus of the laser, you can sort of scan through your sample. You can actually look at the different layers. So for coating it's really nice because the top layer usually is different from the bottom.
Another custom-made setup allows to measure the Raman spectrum in bulk samples.
This can tell you how fast a coating is curing, so how, let's say, how much time you have between mixing all the components and application. And it also tells you what the extent of conversion is, so how much of your reactive groups in the coating have actually reacted. And the nice thing is that you can just measure through the glass foil.
Here, the lab has cleverly upgraded an EPR spectrometer.